Okay, so don't forget this. Constructors with no arguments, that is the default constructor. It can be a little confusing. It's different from standard functions with no arguments. Remember that if you have a function and the function doesn't have any arguments, you call it with function name and open close parentheses semicolon. So if you have a regular function with no parameters, you do need the parentheses. Now, that said, if you have an object declaration and you have no parentheses, that means what you're doing is you're calling the default constructor. So this is the correct way to call the default constructor. Okay? If you put parentheses in here, it may not give you an error message, but as we saw just before in the previous video, what does C++ compiler consider this to be? The compiler, what it sees is a function declaration or a function prototype. It looks like it's saying that somewhere there is a function called date, not an object, a function with no parameters, no arguments, and it returns an object of type DOU. So it won't give you an error here, but as soon as you try to use this object date, remember we saw that in the last video, you get error messages. Okay, so it's one thing that'll drive people nuts when they get this error, but can't say I didn't warn you. Okay, you can, there's multiple ways of calling the constructors. You can set up you can set up a specific constructor arguments, and you can call just like any other standard member function call. This is a convenient way of setting data members or member variables, and remember that this method is quite different from standard member function call. So for example, if you want to call the constructor with two parameters, you pass in two arguments, in this case 7 and 4. Okay, so, and then if you want to call it again, you just call it to reinitialize, and you can say holiday equals, for example, this the name of the constructor and then some new parameters. So in this, new arguments. So let's say your first time around you call it with 7.4. You decide, well, I need to change the data members. You can call it this time around with 5.5. So let's just try that. Oops. Here it is. Okay. So we set up this XYZ class. This was about 2 videos ago, and we said that we're going to have an object of type, an object named X of type XYZ with the values 3 and 5.45. So now we're going to say, well, what we really wanted was an object X to have XYZ with the values 1 and 3.1415. And this is perfectly fine. And let's say we test it out. First over here we say cout, and we say initially X has a data member x. Sorry for the use of the x variable all over the place. Not purposely trying to be confusing, just trying to be succinct. And then we change it and we call this again. And we say now. Alright, there we go. So initially we set the x data member. Just check that. Yep, it's x in. goes in as the first thing. So used to initialize the X data member. Perfect. So 1 goes into X, so we should say X has data member X, and this, sorry, X has data member 3, and the second time around it should say X has data member 1. Alright, and let's run this, compile and run, and it says X has data member 3, and now X has data member 1. So you could say that, well, this is sort of using it just like any other function call. So yeah, I guess in that way, it is sort of like a standard member function call, but it's quite different. It's reinitializing the complete object. And actually, what's really happening behind the scenes is that when you call this call, let me just zoom in right here on this thing. When you call this, what it does is create a brand new object independent of holiday. And then what you're doing is you are saying now holiday is actually this object. Okay, so for a while, very briefly, you have two objects. One is holiday with 7 and 4 inside it. Now you create another object, 5 and 5. It's a totally different object, and then you're saying, okay, now actually holiday is going to be that object that's assigned back to holiday. So yeah, so I guess you could say that you can call the constructor explicitly. This is a very special case. It's not exactly the same as a regular function call. It works completely different. You are creating a new object, and then you're saying that, well, okay, holiday is this new object. So you can, I guess you can argue on both sides. It sort of looks like a regular function, only you don't have class name or object name before it. You don't say holiday dot day of year, so you cannot do that. But you can call it and then assign the value to an existing variable if you want to. So you're reinitializing that variable. Just like in Java, default constructor is a constructor with no arguments. You should always have one. You don't have to. When you do not have any constructors at all, it is automatically generated. So is it always automatically generated? Actually, no. If you have no constructors at all, then you do get an automatically generated constructor, automatically generated default constructor. If you have a single constructor with just one argument, then you lose that default constructor. And this is the same rule as in Java. So if you do not have any constructors, you get one for free, the automatically generated one. If you define one constructor with an argument, then you lose that default constructor. Most of the time this will work, but remember that if you do not have a default constructor, you cannot declare an object like this, say class name and then object name. You cannot do that. That is with no initializers in parentheses. So sometimes you want to do that. Sometimes, to force the client class to pass in default values for all member variables. But a lot of times, I think in general, most people would say you should always define one and initialize all your data members to something like 0. That would be good. Okay, class member variables can be of any type, including objects of other classes. And later on, we'll see that we can have objects of the same class, and that's may not make sense at first, but something that will come in as tremendously useful much later on. Okay, so you need a special notation for constructors so that they can call back to the member objects constructor. So if you have objects inside objects, there are certain ways of doing this. We'll see later on when we get to pointers. Sometimes you might prefer pointers. I'm going to hold off on that discussion for later. But you do need some way for your constructor to call the member objects constructor. So if you have member objects, that is not just ints, floats, doubles, but objects, then you need a way to be able to call that objects constructor. So here's a simple example. We have a class member variable. Let me see what that is. So you have a class day of year, which has only int variables, and then you have a class holiday, which has as a member object or member variable an instance of the day of year class. And if you do that, you can call inside the initialization section of the holiday constructor. The initialization section can have a call to the constructor of this member object called date. So once again, just to repeat, let me just go back up. You have a regular class with just, class with just primitive data types as member variables, just 2 ints, and it has a constructor that takes 2 ints. Now you're going to have a class with an object inside that, any object of type holiday. And if you want to initialize this date, this member variable date, which is an object, you can use the constructor in the initialization section. Okay, so an extremely useful way of initializing objects. In the initialization section of holiday, you can call the constructor of an object. Okay, and other things are pretty much normal. You don't want to look at any of this. You might want to take a look at the complete example. I'm just looking at the the important parts. Okay. So there are, as we saw, C++ has 2 ways of passing parameters. One is passed by value, and the other is passed by reference. Passed by value is what we have in Java, and unfortunately, passed by value sometimes has excessive overhead. So, for example, if you're passing in an object, that's where the overhead becomes especially significant. So if you take a look at this, let me skip that. So call by value is what we have in Java, and this is what we used all through Java for all the classes that you wrote. If you have a parameter that's passed to a method, and it's an object, for example, a string, in Java, what happens is you're actually sort of under the hood, you're really passing by reference. Although it doesn't look like it. If you're passing an object, you're passing by reference. If you're passing a primitive data type, you're passing by value. So I remember I said that in the case of Java, it's always passed by value. Actually, it's only sort of true. For objects, it's primitive data types, it's always passed by value. For objects, it turns out it's always passed by reference. Okay, so the idea, take a look at that video that talks about the differences between passed by value, passed by reference, or call by value, call by reference. For simple data types, there's almost no difference in efficiency. As far as the reason we use call by reference really is for efficiency. It is the most efficient method of passing parameters if you have objects. If you have classes, let's say each object has something like a 10 megabyte JPEG image or something, then every time you call a function, you might be making a complete copy of this 10 megabyte JPEG image, and that becomes very inefficient. For efficiency, you want to use call by reference. Okay, so it's especially for large data. It's good to use it's desirable to use call by reference.